Alright, so this is group 8 doing problem number 3. Our transfer function is 10 over 10s plus 1 times 4s plus 1. We're going to separate this into 3 separate transfer functions, t1, t2, and t3. So we're going to have t1 equals 10, t2 equals 1 over 10s plus 1, and t3 equals 1 over 4s plus 1. And looking at these individually then, so we can add them up together later, t1 is going to be 20 log of 10, and that's going to be at 20 decibels constant. T2 is minus 20 decibels per decade at omega equals 1 over tau when tau is 10. And similarly with T3, we have minus 20 decibels per decade at omega equals 1 over tau where tau is 4. And so when I plot these on the magnitude Bode plot, we have T1 constant in red here at 20 decibels. T2 is in orange here, and it's going to go 0 until it hits omega equals 1 over 10, and it's going to go down 20 decibels per decade. And the same with T3, but at omega equals 1/4, it's going to go down 20 decibels per decade. So when you add all these together, you start out at 20 decibels until you get to omega equals 1 over 10, and you're going to start going down by 20 decibels per decade until you hit omega equals 1 over 4, and then these two will add together for minus 40 decibels per decade, and then you can smooth out your curve after that. And that's the magnitude plot for the transfer function. And then for the phase, for T1 is going to be constant at 0 degrees the whole time, so that doesn't matter on the phase plot. And T2 starting at 1 over 10, omega equals 1 over 10, you're going to have a minus 45 degrees phase shift, and that's going to start at 10 to the minus 2 and end at 10 to the 0, which is 1, and then it's going to be constant at minus 90 degrees. And the same thing happens with T3, except shifted over to omega equals 1 over 4. And then when you add these two together, you get this blue curve for your phase. And those are the Bode plots for problem 3.